Hi everybody. Today we're going to be completing the 3.1 pre-post learning concept check. You can see this is an introduction to ionic compounds and covalent molecules. So what I want you to do is to read through each one of these statements and respond with a plus, check, or minus in the before column. Hit pause, give yourself a minute to do that, and then hit play again. Okay, the first thing that I want you to know is that objectives 1, 2, and 3 go together as a chunk. And you're going to find that we use a lot of language and terminology to explain those concepts. 4, 5, and 6 also go together as a chunk, but they're a little bit more mathematical and technical in nature. So I'm going to highlight these all the same color, and they get taught as a chunk. Now also, down at the bottom of your paper, I want you to write a couple of notes. So I've already got the notes written. I'm going to talk about them just for a minute. You hit pause, and then when you're ready, hit play, and you'll hear me talk about them. So the first note is about electronegativity. Electronegativity is defined as strength of attraction for bonded valence electrons. And you'll see it comes into play right up here, and then it also comes into play right here in objectives 2 and 3. All right, what we do basically with electronegativity is we use electronegativity values and the difference in electronegativity values to classify bonds as either nonpolar covalent, polar covalent, or ionic, and then also to describe the location of electrons and polarity within a bond. All right, I also want you to take out your periodic table, and there's a couple things today that we're going to be writing in the periodic table. Now, you can see that I've labeled this upper right-hand corner as high En for elements with the highest electronegativity. And also down here in this corner, I've labeled this corner, the lower left-hand corner, low En for low electronegativity. If we flip this over to the back of the periodic table, you can take a look in this little periodic table on the back. This is a table of electronegativity values that's right here. I'm going to zoom in so that you can see some of these numbers. Now remember, in the upper right-hand corner, we wrote highest electronegativity. You can see that fluorine has the highest electronegativity on the periodic table. It's got a value of about 3.98. You get a cluster of a couple of around here that are high 2s and 3s. And the further you get away from this corner, the lower and lower and lower the electronegativity gets, until you get to the element with the lowest electronegativity, which is francium. So that's why we wrote highest electronegativity here and the lowest electronegativity down here. Okay. Next note that you take on your pre-post learning concept check is about transition metals. Okay, so copy that down, hit pause, and when you're ready, hit play. So transition metals, remember, they're located in the D block of the D block of the periodic table, and I'll show you where that is in just a second. Most transition metals, they can take a variety of charges, but there are 3 exceptions, and they are silver, cadmium, and zinc that take +1, +2, and +2 charges respectively. So let's take a look at the periodic table, and again I'm going to ask you to write these notes down on your periodic table. So this is the D block of the periodic table. Remember, it goes S with these 2 columns, P with these 6 columns, D with these 10 columns, and F is down here at the bottom. And that corresponds to the number of electrons that can fit in the S, P, D, and F sublevels when we're writing electron configurations. So again, transition metals, most can take a variety of charges. These are also called D block elements. And you can see that I emphasized right here the 3 unusual transition metals that take fixed charges. You can always find these really easily because they're in the upper right-hand corner of the D block section, and they make a backwards L, and they go +1, +2, and +2. Okay, thanks a lot. This is an assignment. You can snap a picture of this, and you can upload it to Canvas.